So next we'll have Ivan. Ivan is a DevOps engineer in London, and he's going to talk to us about one API to root them all and the rise of the operators. Okay, so welcome, Ivan.
Thank you very much for having me. My name is Ivan. I live in London. I've been in London for 15 years. I'm from Barcelona originally. I have 3 children and I don't sleep. So one of the things that I do is me and Milos and Peter, we organize the Kubernetes meetup in London. They usually come around 200, 300 people. In these meetups, we see a lot of people strong with Kubernetes. So I decided to create KubeCamp, which is training for the community, Kubernetes, Docker, and Prometheus. It's around, you pay £150 per day, and it's very hands-on. It's the idea of helping you to start with Kubernetes, because Kubernetes is complex. Kelsey makes Kubernetes very easy, but it's quite complex. Right? So I've been working with Kubernetes in production for almost 2 years, maybe 2 years, I don't remember. Different places, home office, Sky. I'm in Soho House, in Camelot. Camelot is the people who do the lotteries. So today we're going to talk about Kubernetes a lot, and the operators. Operators is something that has been created recently. It's a term that has been created recently, and it comes from CoreOS, and they have a few operators, and we'll see a little bit how it works. I was to do 3 demos. Let's see if I can do it. The first one is very simple. I know that I have it's that explains why. So we're going to do a very simple demo. It's basically to create a website and publish it in Kubernetes. So what do we do is usually we start our editor. This noise is very annoying, right? And then, I don't know, we can put this took, it's something like this, right? Then, so we have a website. Now, what do we do now? We build a Docker image. Now we can run this Docker image in my laptop, and I can run it in many places. So I have a few clusters. So what we're going to do is kubectl run my website. Matt, yeah. I do a lot of typos as well. Okay, so by doing this, what we've done is basically to tell my classes, I want to run this website. And we have, because I forgot to push. Which it helps me to show you another thing of Kubernetes. I just deployed, right? I deployed my application here, and it failed because it cannot pull the image. But so what's going to happen is that at some point the image will arrive to the Docker Hub, and Kubernetes will pull it. I don't have time for this, so I'm going to delete this part. And the scheduler will create another one. You can see it here. And hopefully this one will be good. Right, so now okay, and what I'm doing now is trying to access to this pod from my machine. So if I come here and I do localhost, in theory I should be able to see the website, right? Excellent. So what is all this magic about Kubernetes? So let's publish this into Google. So the only thing I have to do now is this again. And now, if I go to Google, I'm creating this, right? And in the meantime, I can go to Playground, which is in Amazon, and do the same. Excellent. Right, so, and I just got my website and I published in 3 different clouds with 3 commands, right? That is what has changed from a few years ago when we used to create all these websites and try to manage all the infrastructure. Now we have containers, and containers have the ability to be dispatched, right? Who is using Docker in production here? Anyone using Kubernetes? 3, okay. You will end up doing it. So I like to explain this, the story of 2 contracts, right? You have 2 contracts. You have the contract between my application and the host, right? My website has to run somewhere. And in the old days, we had this machine where we'll go and configure Nginx and then do certain things. Now we don't do that anymore because my host only has to run one thing, and that's Docker. There's the contract between the machine and the rest of the things is very clear. It's called Docker. Machines only speak Docker. CoreOS has an OS that everything runs in containers, for good and for bad. Right? So the other contract we have is Kubernetes. Kubernetes basically defines a contract in all the other resources of the infrastructure or the business. We will see that Kubernetes speaks a much higher level language. We don't speak about machines, we speak about applications, which is very important. So one of the things that I do is basically onboard teams in Kubernetes. I go to a client like Soho House, and I help them to start using Kubernetes. And one of the things that happens is that what would happen in your company if your deployments were free? If you could just press a button and deploy anywhere, the way that I just deployed in 3 clouds, right? And what happens is that the velocity increases a lot. And the freedom of a developer to do testing and trying things, right? Velocity is very important. Kubernetes, Google always thought that the big thing about Kubernetes was going to be resource utilization, and it's true. You can save a lot of money in infrastructure. It's around 45% in your Amazon bill if you use Kubernetes that if you don't use Kubernetes. But to me, for the business, the biggest value comes from the velocity. So the other thing that happens with Kubernetes is that it allows us not just to use composition. Composition is extremely powerful because we've been there many times. We're going to create this library script application that we can reuse, right? Well, yes, but because we have to run this in environments and the context changes, then our big idea gets a little bit diffused. So let's look at Nginx, for example, the idea of running in a VM versus running in a pod in Kubernetes, right? So we have Nginx, the pink Nginx. Nginx have the Nginx conf, and then we have the virtual host, and we have one, the default one, and then we have one that has certificates. And you could have basic auth or other things, right? But basically, is we have the Nginx, the runtime, and then we have a set of configurations. And if you have a machine, you have to make sure that all this stuff goes to the machine. And that's what changes. Because with the pod, what we have is to have one container that is my Nginx container, and then we have a config map, which is a Kubernetes resource that allows us to define a set of properties and add them to the container as a volume, or as a file. So we can have one for the Nginx conf, another one for the default. We can have secrets, Kubernetes secrets, to get the certificates and mount them as files. So suddenly, what we're doing here is not managing scripts and files and machines. What we're doing here is defining a YAML file that describes what we want to do. We give this YAML file to the cluster, and the cluster says, oh, I know what you want. So in Kubernetes, there's something called ingress controllers. And the ingress controller is basically the resource that is in charge of getting your public traffic into the cluster. And that's something that is usually difficult for people to grasp. So now you have all your CLVs or your load balancers and HA proxies, and then go to your machines. Okay, what happens is that you have a cluster in Kubernetes. Right? What I was doing here, when I was doing this kubectl forward that I was doing here, what's happening is that this pod is running in my cluster, and I don't have access to that. So what I do with this instruction is to allow my machine, whatever, to connect to this cluster and access the pod, right? And that is something that is important. All your applications run in the cluster. You have to define how you want to access the traffic, right? So the ingress control is basically that. It allows you to define all these rules. If you request this host and this path, I know which Kubernetes service I have to call. So what is an operator anyway? Because I've been talking about operators and stuff that is a little bit. So an operator is basically an abstraction, something that you can define to help you to manage infrastructure and applications, right? Because what we want is to end up with a set of APIs. Config management, who's using Chef or Puppet? Ansible, right? All these config management tools have a big flaw, and is that they're tools. And a tool needs someone to manage a tool, right? They have a hammer, and the hammer needs a person that can be more or less skilled, and I can build a shed or a little house or furniture. I build furniture for my children, pink especially. It happens. But you have the tool, but you still need someone. And the difference is that you can have a robot, and the robot can do a few things. I think that here in Spain you have these robots that basically are Hoovers that go cleaning your floor, right? That's what they can do. They can do a very specific thing. If you want to change them, well, you need a different robot, right? And it's the idea of having all these APIs. You turn all these things that you were running somehow into APIs. You can automate now what Chef and Puppet failed to do. And Chef and Puppet, they provide an Ansible, they provide an API. But you have to think, well, a tool that provides an API is not an API. Think about it. Because at some point you will say, you can turn your friends into APIs if you want. So let's look at what is inside of the box, right? Let's look a little bit what is Kubernetes and what do we have inside. Cats. So this is Kubernetes. Big picture, we have an API, and then we have state stored in etcd. We have the scheduler, the control manager, and the kubelet. These three guys are the ones who basically do the heavy lifting on running my systems. Then we have the kube proxy that allows me to access different things and other things, right? Other tools, which is good. That's a really good platform to build. But what happens at companies, businesses, they don't really want to run Kubernetes. What they want is to build something that makes sense for them, something that makes them make money. Right? And then they need other things, like I need to manage my users, and I have to manage my databases and all these other things that Kubernetes is not very good at doing yet. Because what we really want to do is to get all these other things and put them in this API. Yeah? Remember these two controls that I was talking about? Now you have the possibility of putting these things inside. And then we convert these different things into APIs. And you end up with this. Right. You have your Kubernetes API that allows you to define a set of internal APIs and external APIs. This is basically about managing your business. This is not infrastructure. It has some parts of infrastructure, but it's about business. So how did it happen? How did we get from I have to run my scripts to have this API? This is not magic, is it? So there are a few things that Kubernetes provides that allow us to extend the API server. One of the good things that Kubernetes has is the API, because the resources, all the objects that have been defined there, makes a lot of sense. And now, with the third-party resources, we can define our own objects. So this is a third-party resource, right? It's a YAML file that I define. I say, I want to have an object type Postgres, and I want to have in this qualified domain. And then when we submit this YAML to the cluster, what happens is that the API server creates an API endpoint for us, so we can hit this Postgres endpoint. We can create and read and update and delete objects, and we have a watch API. We have events, which is very important because we all know, especially now with all these Lambda architectures, that events with composition allow us to build really flexible and resilient architectures. So you can understand, or you can get the third-party resources as the data model of my controllers, right? The model view controller pattern that we have from forever, you can apply the same thing here. But remember, the data is just one part. The key here are the operators or the controllers. That is what is very important for your business. And when people ask me, oh, I built around 7 operators in Soho House. Oh, can you share them? I say, well, they do something very specific for Soho House that probably does not work in your business. The way that you handle your LDAP or your users or your reports or your backups or whatever, it's very personal to the company, right? But the pattern is there. If you can have this pattern, suddenly you can delegate on a piece of code that does something. And you don't have to do it anymore, which is good. So one of the first operators that I created in Soho House was the Postgres operator. And the Postgres operator is very good. How of you are developers? Okay, a few. So I can tell you something that happens. I'm a developer. My background is development and architecture. I'm not very comfortable with ops. But one thing that happens is that to create an RDS, you can go to the Amazon and click, but you need someone to do it. If you want to automate, you have to run all this craziness because Amazon has this API that is a little bit convoluted. So defining an RDS, creating an RDS is not straightforward. And you have different, you can do it with Bash, if you're very brave. You can do it with Terraform, doesn't really matter. At the end, what happens is like, I will define a set of parameters here, and I want the system, the cluster, to create that for me because I don't know how to do it. I have better things to do than writing stuff to create databases. Good. So that's what we do. We create this operator that encapsulates all the logic about creating databases, Amazon, or in the cluster. Now that Google finally has Postgres in the cloud, we could add Google. And the same way that I just created a website in 3 different clouds, we could go and create 3 different databases in 3 different clouds with just a YAML file. And this is how it was in reality. I have my YAML file, I submit it to the cluster, and then I have the operator that is watching this API. And then when a new object arises, oh, I have a new object, I know what I have to do. So we call Helm. Helm is the package manager for Kubernetes. It's like brew in OS X or the apt-get install. And the joy of Helm is that it manages charts that basically is a set of resources. When you're deploying, usually you don't want to deploy one container or one pod. You want to deploy a set of resources. I want to have my pod Like the example of the Nginx that we were talking before. I want to deploy my pod, and my pod has these config maps and this secret. So I want to have that thing wrapped somehow in what I understand as a release. And then when I send it to the cluster, Helm gets all these resources, put them together, and put them in the cluster. And I can roll back and upgrade them and update them in the context. And Helm knows which YAML files change it, and then he knows what we have to do. And because if you have to do it manually, you have a big system, and you have to manually manage all these YAML files, it becomes a nightmare. So this is basically what happens. And then when this thing arrives to the cluster, a task will kick in, and it will create the RDS. Something I forgot to say is that I do everything in containers, absolutely everything. I don't do, so in Camelot, for example, I arrive and they have this little tool in Python, and they said, oh, to run this tool, you just have to go there and do all these commands, and that's it. And I try to do it, and yeah, my virtual M doesn't contain all these dependencies. And oh yeah, but once you have all these things set up, that's it. You are free to go. I say, well, or we can create a Docker container, and then the only thing I have to do is Docker run. And I don't have to know how the dependencies and the system has been set. I just want to run that command. I don't want to spend time setting anything. So that Docker container that creates the RDS will be called by the API server through all this stuff. One of the things I did is to put nuts. Who doesn't know what nuts is? So nuts is it's a queue. It's a streaming queue. It's very lightweight. It's written in Go, and it's very good. Lightweight, and it works. And usually when I put this thing, people start complaining about nuts and say, oh, what happens if nut goes down? What happens this? What happens that? Easy. So we put nuts for a reason. We put nuts because my developers in Soho House don't have time to learn Kubernetes. So one of the things that I do when I go to work with company is help them and basically handhold them until they're comfortable doing these things by themselves. And it takes a while. It takes 3 or 4 months until you feel comfortable dealing with Kubernetes. But they have to release and do stuff that sometimes, and more, you want to run things that need to know what's happening in the cluster. And then the way of doing that is, well, I will go to the API server and ask the API server, tell me what's happening. Tell me how many pods, or if I have a pod that is running a backup, or if I have a pod that is doing something. And if it happens, then I will hold off or will not do whatever I have to do. And that's something that is very easy to do if you know the API. What happens if you don't know the API? Well, I define a queue, and then developers can subscribe to this queue. And that is basically what I end up doing with all these operators. I turn them into this. We have the queue, and then the operators consume the queue, and other people can consume the queue as well. And because this model developers understand very well, and they feel comfortable, and they're very productive. And little by little, they keep learning about all the other things. So what we do is to remove the friction of starting with the technology like Kubernetes. So this is basically the diagram of how things works. We have a key, we have a set of webhooks that interact with GitHub and Salesforce and other things, and then we have our logic there. So let me show you this nuts thing. So I have here my queue, a guy listening for events, and my operator. And my operator is going to do one thing. In Kubernetes, when you create a namespace, usually you want to have a few things defined in the cluster. In fact, what happens is that when you define a cluster, you want to initialize that cluster with some secrets and some configs that you will need to do whatever you have to do. So you have these 3 blocks: is creating the cluster, initializing the cluster, and finally releasing your environment, right? And it's the same pattern here. This operator will go and initialize your namespace. I'll show you an example. What we do at Soho House, we basically work with one namespace, but if a developer needs to have a sandbox, only for him to deploy this version of the net and this other version of this service, he can do it. But these people then need to have that sandbox initialized with all the secrets and all the credentials to access all these places. And that's what this guy is doing. And he's doing it basically by calling Helm. And Helm defines a template, say, well, for this release, for this namespace, you need to have all these 3 secrets and this map, okay? So the concept of namespace, for the ones that are not very familiar, namespace is basically a virtual cluster inside of a Kubernetes cluster, right? So we have 3 namespaces. Now I'm going to create a new one. Now I check my namespaces and I have Madrid. And if the operator has worked and has done what it has to do, I will hope to see a new secret in this namespace, and it didn't work. Let's see what's happening. So these are the logs. I know what's happening. It's not reading the namespaces. This is the logs of the event listener. This pod is listening for events and publish them in nuts. And this guy oh yeah, we have one. So where are you? Well, I don't know what is creating this secret. So it's basically this. I don't know. It's, of course, before doing the presentation, I just did it, and it worked. Now I have a live demo, and it doesn't work. Why? I don't know. So basically, what we've done is when I create this namespace, T1, it creates this secret here, right? And this secret can be whatever you want to put. That's not the important bit. The important bit is that the only action that you do is to create a namespace, and that triggers an event that the controller picks up and then creates resources in the cluster for you to do whatever you have to do. Okay. There's always one demo that doesn't work. It's a shame. So, if you start doing these operators, you have to remember one thing. If you are doing tasks, if you're doing tasks, it's better not to do an operator. It's better to delegate on Kubernetes using the Kubernetes jobs. Kubernetes jobs are extremely confusing for people because they are not jobs, they are tasks. So when you run a Kubernetes job, you can only run it once. Once you run the job, that's it. You cannot run it again because you run it. So the name is a bit misleading. It should be a task, and then people will understand better. And then you can orchestrate with health checks, right? Creating a database, initializing creating the instance for the database, initializing the database, migrating the schema. These are things that are basically sequential, and that's what we used to have in the operator, and we removed. Because the operator is a black box, for good and for bad. You put all this stuff in the operator, and then you don't have to worry about that. What happened was that the developers were making assumptions on the black box is going to do all this magic for me when it was not. So we decided it was too risky to have all these things, all these assumptions spread across different things. So then we say, well, you are a developer, you are in charge of defining which task do you want to run as part of your release. And you have to create a database, you can create a database. And with the health checks that we have here, we allow the cluster to know when you're ready to carry on doing the next task. So you can schedule tasks. You can run 3 tasks at the same time, create an instance, create a database, and upload some data. And what happens is that you check if things are ready, right? So I create my instance, and my create database is going to check if the instance is ready. If it's not ready, I'll wait, and if it's ready, I will run. And then the migration is checking if the database is there, and if the database is not there, I'll wait, or I will die, and Kubernetes will spin a new instance for you, a new job for you that does exactly the same thing until it succeeds. So you don't have to worry about these things. So all these things allow you to create your applications and focus on what is important, right? The example that we saw before about the website, we're going to do it now the way that we do it at Soho House, for example. So in Soho House, we use Drone as our CI. And what happens is when I build a project, right? So if I don't know what I have here. So if I do this is what the developers do. They go and push, and we create a new branch. And in theory, I should go to my drone. My drone is down. It's because I'm not in the VPN, but it's fine. So in theory, it should build, and at some point in Slack, we should have a message here saying that I've built, oh look. I think that people in the back cannot see it, so I just built my application, my project, and then we have the access to the application. So I did git push, and now I come here and I click, and probably would say you don't. Oh, yeah, it doesn't work. Oh, it's because it takes time. It happened to me once. So you do git push, you get a notification in Slack, you go to the page, it takes a while to reload. Let's see if by the end it's loaded. And then that's it. Context code. I don't think I can, it's fine. So what we've done is to publish my website into, at some point it will work, into another cloud, right? So writing an operator is hard. It seems that it's simple, it's hard. Because remember what I said about the robots, right? You make them do one thing and they will do it. And it's harder than you think. Even if people help you and you say, well, maybe you can give me a hand with this, you will struggle. And one of the things that I've seen over and over again is that people get very attached to the systems, tools, things, and what happens is, home office, for example, we had this tool called Cubator to deploy our releases. And that was exactly what Helm does for you. But by the time that Cubator was created, we didn't have Helm. Rimas was creating the monster. And so what happens now in home office is that they're still using that tool because it's a tool that we use. But we, in the community, we have moved really fast. It's one of the main problems we have with Kubernetes. It moved very fast. Right? And now we have Helm and we can manage releases with Helm. But they're still using that tool. In Camelot, they have the same thing. They have a tool that generates all these templates that do all these things and sends us to the cluster. And now we're in the work of rewriting all these templates to use Helm. Why? Because Helm is a standard way of doing these things. We don't have to reinvent the wheel. So I'm just finishing. Ha! Finally. It's because we're using an Nginx controller. Nginx controller, you have to make sure that you reload in Nginx at the right time and doesn't cause many trouble. And the more rules and virtual hosts that you have, things happen. So it takes a while. But yes, finally, it was. But that's not what I wanted to show. What I wanted to show was, if I come here now, this is the project that we just changed. I have a branch, right? So you can do a pull request, you can do whatever you have to do. We usually push to a branch, and then that will publish you or deploy your stuff into a cluster. And then when we merge to master, it goes to production. And at some point, we go and click here and delete the branch. And now is this webhook that we call a controller that will go to my cluster and remove all the stuff that it was created when we saw this, right? When we got this message, it means that Kubernetes has now an Nginx pod, and it has an ingress rule, and it has a secret. And now I just finish with that, and I just delete my branch, and the branch is deleted. And again, it's making things that developers and business wants to do without having the friction of, oh yeah, but if you want to do this, we have to run this tool. Oh, you have to do. We have all this automation now that allow us to streamline the process, right? So the journey might be a little bit bumpy. I always advise people, when they get into Kubernetes, to understand what they're doing. That is not going to be an easy path, right? It is bumpy, but it's worth it. Thank you. Questions?
Hi, thank you for the talk. I would like to ask you a question. What I didn't get, what is the benefit of creating an RDS instance with the Kubernetes YAML instead of Terraform file, for example? Why would I want to inject all this stuff into Kubernetes API? Because I think you create an instance once, maybe 2 times, so you can edit Terraform file, and it's as well versioned, and you can do all the stuff which you really would do with Kubernetes. So what is the benefit of merging that stuff into the Kubernetes API?
Good question. So what I said is, you get this Terraform and put it in a container. Okay? If you remember what I said, is the process operator is the first one that we created and we dismantled. And we created tasks, because as you well said, you have a task with this create an instance that happens very rarely. So what you don't want is to create an instance per database. That's the issue we have with the operator. We will create an instance. Remember my example of the robot? Yeah, well, but if I have an instance that is not used very much, I can create my database there. Then you start putting all this logic in the robot and making it very complex, and bad thing happens. When in reality, as you said, it is very simple. The only thing you have to do is to create a task, which is basically to put a pod. Because what you're doing is delegating the execution of that into the cluster. So why do you do it? It's because you have this container, and then the container is the one who's going to do the task for you. Because then you can do it, and she can do it, and he can do it, or a system can do it. And it died. Right? But that's the whole point of doing it. What you're doing with this is exposing this functionality to anyone. Anyone who can consume that API can basically create an instance, right?
Thank you. And the other question was, you're basically teaching people to use Kubernetes, right? So how do you convince them and teach them to learn all these crazy YAML stuff that Kubernetes that you need to write to use Kubernetes? Because I work with people that wouldn't do that, probably, because they just won't. Maybe they would say, I'd rather learn Docker Swarm, which is far easier YAML file and far easier YAML syntax. It has less features, but it might work. And I think it's really tough for people to dig into Kubernetes because of these crazy YAML syntax. How do you handle that?
It's not only the YAML. I mean, it's a complex system, I know, right? And the thing is that what we do is to start using a lot of YAMLs at the beginning, so you will get familiar with all the objects and all the resources. But then we move away from that because we use Helm. And Helms allow you to basically group and manage your YAML files for you, kind of. It's a template engine, like Jinja or something like that, right? So it becomes much easier. The people at Soho House, what they do is we have one project, and that's the net. And the net is the one that basically is the spear that goes into, I will try things there. And if it works, then the other ones adopt the same pattern. We use drone, so you have all the build and the deployment defined in one YAML file. And then you have all these charts that you have to create. And they are very similar. If you are so Soho House is Ruby. The majority of YAMLs are the same. Camelot is Java. The majority of YAML files are the same. So you don't have to rewrite secrets and config maps. What you do basically is what? Is this kind of things. This is the important bit that you want. This is my chart for deploying the operator subscriber, right? That's what you spend time trying to figure out, but you don't write, let me see what it is. You don't write these kind of things very often, so you add your embars or your secrets, but so Helm helps a lot.
Thank you. And the other question might be, and from which point would you recommend to use Kubernetes? If the company only has like 5 servers and they can name their hosts from their mind, do you think they need to use Kubernetes or some sort of orchestration?
You will need orchestration. Which one? It's up to you. Docker Swarm with SwarmKit is very good. If you have a simple setup. Now remember, it's like Nomad and Docker Swarm, they are orchestrated. What they do is to schedule pods. But Kubernetes does a lot of other things for you. Right? And so if your pod dies, I will make sure that it starts again. If you need to have this kind of health checks or access, I provide all these other resources. So if you need all these things, then yes, use Kubernetes. If you don't need them, if you're doing crunching data and you have all these servers that you can name, then maybe it's not the right solution for you yet.
Okay, thank you.
So when you do the deletion of the branch and it's going to the controller and the controller is going to remove a lot of things, how do you keep track of these things that is deleting? It's always like hard code, you always say like, for this branch I'm going to create an ingress, a pod, and this, or do you keep it in another storage like etcd or something?
So we use Helm. And Helm has the releases in which context are in the wrong context. Right? So I can come here and modify this one, or I can roll back. I'll try to put the VPN. And then you can see it, but it's basically Helm. Helm is the one that installs, and Helm is the one who deletes the resources. We delegate in a tool that knows what to do. I don't have to do it, because that's one of the issues we had at the beginning. We have to manage all these YAML files that our good friend said this is bonkers, and I agree. And then, but that's what the sanity comes from Helm, because Helm allows me to do things like rollback, or I can check the status of Helm status and this one, for example. And it will tell me what happened and what was deployed. So you have all the traceability, right? Helm puts all the state in the cluster, not using third-party resources, using config maps, right? So if I look at kube system, if I look at the namespace in kube system, you will see that I have all these config maps that Helm has created. So, am I there? It doesn't work. It's fine. But that's basically the answer is Helm handles that for you. And when you have the delete branch, what we do is to call Helm, and Helm goes and delete the release that you put it. And then you can say, well, remove everything, because I don't want to have anything in the cluster, or just remove the release. So you will have in the Helm, in the information, you will have the traceability. So we put these 3 releases, and then we delete this one, and then we put all the 2 more, right? You can go to the cluster and ask Helm about this information.
Thanks. Thank you. So I wouldn't be surprised if I had gotten you wrong, so excuse me if I did, but isn't it the case that you're, on the one hand, you're making a difference between 2 kind of users, the ones who, well, you have tasks, and some users to do these tasks will just use what will be for them black boxes, which are designed and given to them by people who do understand Kubernetes and who understand what is happening. So doesn't this in some way go against the spirit of DevOps?
No, it's the other way around. So, but it's a very good question. What happens is that what we do is to ask people who know. So I go to ops guys who know Terraform. My knowledge of Terraform is like this. And say, can you create a Terraform script to do the RDS? Yes. And then I say, can you put in a container? And some of them say, yeah, no problem. Some of them say, like, not sure if I know how to do it. No problem. I'll do it for you. Once I have the container, I can define the Helm chart. Right? And then it's not only me, the one who can create this task. It's you and you and you. It's all the people who know how to call the endpoint. But because it's a Kubernetes job, what we have is you can use the API, you can use all the tools to do the same thing. So what we do is like people who are very good at Terraform and people who are very good at developing, they do what they're the best at. Right? And what we provide the glue. That's what we're doing here. So if you're very good at doing these kind of ops things, well, do that. And somehow, by putting in a container and defining the YAML that describes what is the state or the desired state that we want to have with this, ends up being used by everybody.
Yeah, but it does compartment things again. I mean, put people in different compartments, and some people will do one thing and not understand the whole picture. We'll just use a...
So this is something that it's very personal. You have, it's up to the person to learn about Kubernetes, or about anything, right? So in Soho, the team that I have, the 2 guys who are really good and they want to learn and they want to know, so they spend a lot of time talking to me and trying to figure out better ways of doing these things. But there are 2 that they don't really, because they are too busy doing other things, which is fine, because we provide the scaffolding for them to keep working, and they all work in the same way. So what we have with the cluster is basically unify the way of working. And then if you want to get your hands dirty, you can. If you don't want to use it, it's fine. You can stay. What happens is that it is true. This merge that we have to do of roles happens, and what we are not doing is forcing them. So if you are ops and you don't want to deal with developers, I'm not going to put and grab you and sit you there because it doesn't work. I've done that. We've been doing DevOps for a while. We know that this doesn't work. It has to come from the person saying, I want to know, I want to learn, I want to help these people. Right? I want to share my knowledge. So I'm very good at Terraform, so I will go and sit with these people and help them, and I will try to learn how they do the other things. Right? What we're doing is removing the friction that you have to do it.
So apart from creating instances, which is something that is kind of confusing because you would normally think about using something like Terraform to create new instances, what examples of resources can you share that are different, so that we have a broader picture of what you can do with a resource?
With the resource or with an operator?
Yeah. Sorry, with an operator. Yeah,
okay,
sorry.
so one of the ones that we have, it's called the Elastic IPs. And what they do, so we have a bunch of integrations with banks and with third parties, and they want to whitelist an IP, okay? The issue that we had is you have a very good way of doing it in Amazon, but in this team there are no ops. So if something happens, they will have to manage it. So we make decisions, okay, you understand what an Elastic IP is and how to assign an Elastic IP to a machine and what labels are. So what we have is you get the Elastic IP, and there's something I said, the assignment of the Elastic IP and whitelisting that in Salesforce in the banks is manual. You cannot automate it because you have to send an email and then you have to call and then you have to do other things that you cannot automate, right? Fine, so we have this IP that now is bound to my staging cluster and has to have a node, right? I can come here. So we have these nodes, and I can label nodes. We can put labels, and then you can say, I want to run this Salesforce integration in a node that has the label Salesforce whitelisted, right? And so machines come and go, as we all know. So the operator is in charge of making sure that we have all the whitelisted IPs assigned to the machines and labeling all these actually, because it's a part of the task involves talking with Amazon API, and another part is basically talking with Kubernetes API. So one thing is like, I want to assign the Elastic IP to this machine, and the other one is when I want to get this node and assign this label, right? And so what they do is to define with a YAML file, in this cluster, I have these 3 IPs, and that's it. The controller will read and say, I will make sure that we have these 3 IPs assigned to 3 nodes, and the nodes have the labels. So the pods can work and talk with Salesforce, for example. Does that make sense?
It is not only a one-off
No,
operation, but it assures as a state.
Yeah, it runs and makes sure that things are the way that it should be, right? It's like the etcd operator that I showed from CoreOS. I don't know what it is. These ones, that's what they do. They do a few things. They start things in a specific way, and if one dies, I will make sure that the other one is joining the class in a specific way. Things like Cassandra and Neo4j and stuff like that, it's very particular, and you have to, at the end, you write something like that helps you. But if you want to know a little bit more, I can show you other things, and I can explain a little bit better how it works.
Thank you.
You're
Last
welcome.
question?
That was the last question. And if you have more questions, you can grab me later.